All right, we're going to talk about notes 100 today, which is talking about areas of sectors and lengths of arcs. So what we're looking at here is circles, okay? But instead of going all the way around the circle and talking about circumference, we are only going to be talking about an arc length from two particular points on the circle. And then instead of talking about the entire area of the circle, right, covering the whole circle, we're just going to be talking about a little piece of it, what's called a sector, right, some portion of the circle. Now, to do these problems, you're still going to have to talk about circumference. You're still going to have to talk about area. So let's do those. Now, this thing starts with area of a sector, so let's go ahead and talk about the area of the circle. So area equals pi r squared. In this case, your radius is 12. All right, whoops, vaguely color code this. Oops, and we need to square that. There we go, got it all in the right places. Cool. So what this is going to be now is area is equal to 12 squares, 144, and we're going to talk about pi here. That's the full area of the circle. If you wanted to coat the entire thing, paint the whole circle, right? Paint the whole thing. You need 144 pi, whatever the units are. As far as your sector goes, so area of the sector, okay, what you're going to do is take the fraction of the circle, so some portion of the circle that we just want to focus on this part. Now, you might be thinking, well, what fraction are we talking about? And you're either going to have an arc measurement, which in this case is 90 degrees, or you would have a central angle measurement. And the central angle measurement and the arc measurement are the same thing. So in this case, we're talking about 90 degrees. Well, 90 degrees out of how much? Well, circles are 360 degrees. So we're going to take the fraction of our circle, 90 over 360, times the full area. Now, I'm going to use a calculator here because I'm going to, all right? Just being fully honest there. So what goes in the calculator? Well, I'm going to do 90 over 360 times 144. So 90 over 360 times 144 is 36. So what this gets me now is this is 36 pi. So our area of our sector is a fraction of the original area, and it is 36 pi. We do not have units here, so I'm not going to worry about that. Now, arc length is very similar in terms of its process. The difference is with area of a sector, we have a fraction of the area. With arc length, you're going to have a fraction of the circumference of the circle. So let's find the circumference of a circle. So I'm going to go ahead and slide this up. All right, circumference is equal to 2 pi r, which means 2 times pi times, what was that radius? There's 12. So circumference equal to 24 pi. All right, 2 times 12 is 24. So for our arc length, I'm just going to write arc here. We're going to take that same fraction, 90 over 360, times the circumference, so 24 pi. What goes in the calculator? We're going to do 90 over 360 times 24 this time. That is 6 pi. So arc length here is 6 pi. I'm going to go ahead and get rid of the calculator. I'll pull it back up as I need it. So area of a sector is a fraction of the area, and arc length is a fraction of the circumference. Okay? I'm going to go ahead and look at number 2. Same exact thing, area of a sector and arc length. The difference is your fraction has changed, right? This arc measurement is different. But as far as the fractions go, we're still going to do the rest of the problem the same thing. So let's talk area here. Area is equal to pi r squared. So area is equal to pi times, this is going to be 21 squared. Remember that calculator I had? I want it back real quickly here. So area is equal to, I think it's 441 for 21 squared. I'm going to double check. Let me move that over. All right, so 21 squared is, yeah, I was right. It's 441. All right, so 441 pi Any units? Nope, no units. Okay. So if we're going to talk about now area of a sector, okay, so area sector here, we need a fraction. What fraction? Well, this is now this arc measurement, which is 120 degrees. So we're going to do 120 over 360 times this full area of the circle. So 441 pi. Whoops, I missed the 1. 441 pi. There we go. Okay, so what goes in the calculator? I'm going to do 120 over 360 times 441. So 120 over 360. Whoops, that's not a 60. There's a 60. All right, times 441. All right. So area of a sector, let's grab a pen here. This is going to equal 147 pi. Again, no units here, right? So for the area of a sector, 147 pi. For the arc length, okay, length is going to get me a circumference here. So I want the circumference of a circle. So 2 pi r. So 2 times pi times my radius was, what was that, 21? All right, it was 21 there. So 2 times 21 is going to be 42 pi. And so if we're going to find the arc length here, I'm just going to go ahead and mark it as arc. Okay, that's going to be the fraction of the circle, so 120 over 360 times 42 pi for my circumference. So 120 over 360 times 42 is 14. So this would be 14 pi. So let me go ahead and mark that for arc length. We don't have units here, or else we would definitely fill in the units for area as something squared, and then the units for the arc length as just those units. Okay. All right, one more of these, same kind of problems, right? We just keep going back to doing the same thing. So area of a sector, we're going to find the area of the circle. So area equals pi r squared. So we're going to do pi times my radius is 4 here. Let's see, we'll put 4 and then square it so you can kind of see what's changing. And then if we talk about area here, let's see, 4 squared is 16 pi. So now let's say I want to find the area of the sector. So area of the sector is what fraction? Well, it's 60 degrees out of 360 times 16 pi. Okay. So let's see what happens if I put that in a calculator. 60 over 360 times 16. Not a huge fan of the decimal here. Never am a big fan of that. So what I'm going to do is hit math. And then if I select the very first thing by hitting enter, it's going to take this last answer and attempt to turn it into a fraction. All right. So if I hit it again, oh, that's the fraction 8 over 3 pi, and I prefer that answer to any kind of decimal answers for these. So the area of a sector here is going to be 8 over 3 pi. Again, we don't have units here, so I'm not going to worry about that part. Okay, let's go ahead and get myself back down to here so get some space going, and let's do the arc length. So again, start with circumference. Circumference is equal to 2 pi r. So that's going to be 2 times pi times, hey, your radius is still 4. So that's going to be circumference equal to 8 pi. All right, so let's go ahead and do the arc length. Okay, remember arc length is you're going to walk along this outside edge from point to point. Area of the sector is you are coloring in or shading in this wedge, okay? So to find the arc length here, we're going to do the same fraction. So 60 degrees out of 360 degrees times 8 pi. So into the calculator it goes, 60 over 360 times 8. Meh, not a huge fan of the fraction or the decimal here. I want the fraction. So if you hit math, enter, enter again, it will take this last answer, that's the A and S here is answer, so take the last answer and try to convert it to a fraction, which is successfully did to turn it into 4 over 3. So 4 over 3 pi, no units here, so nothing to worry about there. So arc length here is, what was that, 4 over 3 pi. And that, I'm going to get rid of the calculator here. I don't think I need it anymore, but we'll see. All right, so there's questions 1, 2, and 3, right? Every single one of them, I'm finding circumference, I'm finding area, and then to find arc length, I'm taking the circumference times some fraction. For sector area, I'm taking the fraction times the area. All right, so that's 1, 2, and 3 for all the new stuff. Question 4 and then question 5, a little bit of throwback to the equation piece of things. Question number 4 says to write the equation of a circle with a radius of 8 and a center of -9, 5. Nothing here talks about standard form versus general form, so I'm just going to use standard form here. All right, my preference, if I can leave it, is this. So let's see what we got here. Center at -9, 5. And a radius is 8. I'm going to do a little bit of cleanup here because I don't like the double negative. Don't like any double signs, really. And I know what I can figure out 8 squared. So let's see what we got here. We've got x plus 9, right? The double negative becomes positive. Let's see, y minus 5 squared. And 8 squared is going to be 64. So that is the equation of a circle with a radius of 8 and a center at -9, 5. And then for problem number 5, we're going to reverse it. I'm giving you the equation. I want you to tell me the center. So that's going to be, let's see, -6 and +2. And I'd like to know the radius. So remember, this is r squared is equal to 49. So if I take the square root, you're going to tell me the radius is 7 because you can't have a negative. All right, so we've got a +7 for a radius with that center of -6, too. All right, that's going to be the end of this notes. I think this was notes 100. As always, let me know if you have any questions or concerns, and I'll see you in the next one.